Let's look at this example for wave equation. A vibrating string has both its endpoints fixed at x equals to 0 and x equals to pi. The motion of the vibrating string satisfies the wave equation. This is the equation with initial condition and initial velocity. Okay, so let's say this is our problem, and the points are fixed at x equals to 0. So this is x equals to 0 and x equals to pi. So this is our x, and then this is our u. So and the equation is u sub tt is equals to 5u sub xx with the initial condition and initial velocity. So let's rewrite the four condition, which is u0t is equals to 0, which is this is the displacement, and the second condition is when x equals to pi for any t also equals to 0. And the third condition is the initial condition when time is equals to 0 and the function is x over 6, and the initial velocity when time equals to 0, the function is set 5. So we want to find what is our uxt, which is uxt we can write down as x multiplied by t. So to use our wave equation here, so we know that uxx is equals to x double prime multiplied by t, and utt, u sub tt is equals to x multiplied by t double prime t. So let's substitute this into our wave equation, which is this our wave equation. So we'll have, and then we want to separate the variables. So we'll have x double prime x over x is equals to t double prime t over 5, and these are equals to negative lambda squared, because when p is equals to negative lambda squared will give us solution. And then we separate the variables for x and t. So x double prime x plus lambda squared x is equals to 0, and another one t double prime is equals to 0. So we can see the characteristics from the auxiliary equation. So we'll have m squared plus lambda squared is equals to 0. Therefore m is equals to plus minus lambda I. Okay, therefore our x is c1 cos lambda x plus c2 sin lambda x, and for t, m squared plus 5 lambda squared equals to 0, m is equals to plus minus set 5 lambda I. So we can write down as t equals to c3 cos set 5 lambda t plus c4 sin set 5 lambda t. So we can write down as our uxt is equals to x multiplied by t. So I just copy this down. This is our x, and multiplied by t. So this is our uxt. Now let's use one by one the conditions that we have from these four conditions here. So condition number 1, u0t equals to 0. This is for the displacement. So when x equals to 0, okay, so x equals to 0, which is x0 multiplied by tt equals to 0. So from here we know that x0 equals to 0, whereas tt cannot be 0. Otherwise we'll have a trivial solution. So when at 0 equals to 0, so substitute from here, from our x here, when at 0 is C1 cos 0 plus C2 sin 0 equals to 0. So sin 0 is equals to 0, therefore C1 equals to 0. Therefore xx is equals to C2 sin lambda x. Next, condition number 2. So substitute again from our previous x that we have obtained. So x pi equals to C2 sin lambda pi equals to 0. But this time, since C1 is already 0, so C2 cannot be 0. And sin lambda pi is equals to 0. And we also know that sin n pi is always equals to 0. So we can compare, therefore, lambda is equals to n, where n is equals to 1, 2, 3, and so on. If we rewrite our xx is equals to C2, therefore, our u x t and x multiplied by our t terms, which is C3 cos. And if we expand C2 multiplied by C3 and C4, so by using superposition principle, so we'll have our new uxt is equals to an. So this is our new uxt. In condition number 4, we also want to find the initial velocity. So we have to find u sub t. So we have to differentiate our u with respect to t. When we differentiate this, we'll have. Now let's use the condition number 3. So condition number 3 is u when time is equals to 0 and the function given is x over 6. So substitute back into our previous uxt. So we'll have an sin nx. Oh, don't forget, this is equals to x over 6. So as you can see, this is a Fourier sine series. So our an here actually is a small bn. So to find an is equals to bn from the Fourier sine series, which is 2 over L, 0 until L fx sin n pi x over L dx. So our L is pi, since our problem here from 0 until pi. So 0 until pi. And our function fx equals to x over 6 multiplied by sin n pi x over pi, which is nx dx. So we can simplify this first. 1 over 3 pi. Now, since we have an algebraic terms multiplied by a trigonometric terms, so we can use bipartite integration. So we have to select our u and dv by using liate, L-I-A-T-E. So we select x, which is the algebraic term, as our u, and dv sin nx. So differentiate x equals to 1, differentiate 1 equals to 0. Integrate sin nx equals to negative 1 over n cos nx, and integrate this again, so we'll have negative 1 over n squared sin nx. So we have to multiply and alternate the sign. So therefore an, we are looking for an here. So an is equals to negative x over n cos nx plus 1 over n squared sin nx from 0 until pi. So if we substitute the value Oh yeah, don't forget the 1 over 3 pi here. So 1 over 3 pi. This one also, sine n pi equals to 0. So therefore we'll have negative cos n pi over 3n. Okay, so substitute again into our u x t. Substitute into here with our new an that we have obtained just now. Therefore, uxt, this is our latest uxt. Now, the final condition, which is condition number 4, u sub t at 0 is equals to z5, which is the initial velocity, and the function is z5. So we are taking back that we have differentiate. We have found uxt here. This is our uxt, and then we substitute t equals to 0, and also our an that we have obtained. So this is our ut at 0. So this will be 0. This will be 1. So bn z5n multiplied by sine nx equals to z5. Okay, this should be z5. Now this is also a Fourier sine series with fx is equals to z5. Now we have our bn z5n actually is equals to bn, the small bn, which is equals to 2 over L 0 until L fx sine n pi x over L dx. So our L equals to pi, so 0 until pi, and our fx is z5 that from here, given here, multiplied by sine n pi x over pi, so nx dx. So if we integrate sine, we have negative cos. So 2z5 over pi negative cos nx over n from 0 until pi. So negative cos n pi over n plus cos 0 over n. Okay, so we simplify this by factorizing n. So this is bn z5n, but we want to find bn only. So bn is divided by z5n, so 2 over n squared pi 1 minus cos n pi is cos n pi. Okay, so we have our bn, and then substitute again in here. So this is our final solution. Therefore uxt, so this is our final solution for wave equation.